Hello and welcome back to IXL tutorials. This is Mr. Duffick and we will be continuing on with our circles unit going to IXL U9, which is involving inscribed angles. And inscribed angles is something you'll probably see a lot when you start doing circles in your geometry class. It's kind of a big topic. It's almost foundational when it comes to determining certain angles and arcs within a circle. So let's get started. So this set of IXL, you're only going to see a few different kinds of problems, and this is the most basic one right here in front of us. So they give us a circle, and they give us a series of chords and a central angle. Remember, a central angle is just an angle that is placed at the center of a circle between two lines. Now, something I want to emphasize is these two lines are not chords. So remember a chord. Let me get my notepad out. So remember a chord is just a line where both endpoints lie on the end or the edge of a circle. So EF, line EF, like that, squiggly, squiggly, would be a chord. Whereas something like DG would not be a chord because although G lies on the edge of the circle, D is not. And it is important to understand that distinction when talking about inscribed angles. So the inscribed angle, the big thing to know about inscribed angles is an inscribed angle is an angle between two chords, specifically two chords. So when we look at this problem here, we see that we really only have two chords, which would be EF and GF. So these two lines, these two chords right here. And an inscribed angle is just going to be the angle between the two chords. So down here. Down here is going to be what we call our inscribed angle. And the big takeaway is the relationship between the inscribed angle and the arc it creates, usually a minor arc that it creates, so this thing right here. Whatever degree value you have for your inscribed angle is going to be exactly half of whatever your arc angle is, okay? Now you might be thinking to yourself, well, there's no angle here or here. What am I doing? Okay, but remember all the way back to IXL U2. The central angle right here, so 86, that is going to be the exact same thing as the angle up here, as the arc up here. So if this is an 86 degree angle, this arc is also going to be 86 degrees. Okay, so we have our inscribed angle here, and that is going to be half of whatever our minor arc is here. Because remember, when we have two chords like this, it's kind of cutting the circle into pieces. We have a circle cut, so we have an arc right here between E and F, and then the rest of the circle is gone. So whatever arc is created by when the chords are cutting out a section, that's the arc we're talking about. So if our minor arc here between the two endpoints of the chord is 86 degrees, that means our angle EFG down here, our inscribed angle, is going to be exactly half. So half of 86 is just going to be 43. Over here, type in 43, and we have it. Okay? Same type of problem here. This is asking for UTV, so UTV is asking for our inscribed angle down here. Okay. Well, if 96 is our central angle and therefore the degree value of our arc up here, what's half of 96? That's going to be 48. Okay. So 48. There we go. Okay. What is the measure for angle JIK? So let me copy this one down because this is going to require a little bit more work. Just a little bit. Okay. So it wants us to know the angle value for JIK. So J, go down to I, go up to K. So it's going to be this angle right here. That's JIK. That's what it wants us to figure out. Okay. So is this an inscribed angle? Well, let's look at it. Is it an angle between two chords? Well, we have KI right here. Is that a chord? Yes, it is, because again, it's a line segment between two endpoints that lie on the edge of a circle. And is IJ also a chord? Again, yes, because both endpoints lie on the edge of a circle. So that's going to be our set of chords, which means this arc right here is going to be the arc that is related to our inscribed angle. Okay? So if we can figure out what this minor arc is, then we can just half it and figure out what our inscribed angle is. Great. Okay, but we still don't have numbers, so how can we figure this out? Well, what it does give us is 106 degrees right here. Okay, cool. Well, what else does it give us? Well, even though it doesn't state what we might have, it does make something pretty obvious without writing down the number. Well, we know our line right here, IJ, is a line that goes from one part of the circle to the other, and more importantly, it goes through the center. So what do we call the line that goes through the center of a circle and it starts at one end and goes to the other? Well, that's a diameter, right? That's just our diameter of a circle. So if that's a diameter of the circle, right, that means it's cutting the circle in half, which means this half of the circle is equal to this half of the circle, or this is just a half a circle. So what do we know about the degree value of half a circle? Well, if the entire circle is 360 degrees, that means this half circle is 180 degrees, which means we know this angle is 180, this one is 106, which means we can deduce what our missing angle here is, depending on how they add up to 360. So we'll go 180 degrees plus 106 degrees plus, I'll put X, we'll call that angle X right now. Why not? And equals 360. Okay. 180 plus 106 is 286 plus our missing angle X equals 360. Okay, now we're going to get the X by itself by getting rid of the 286, so minus 286. So we have X equals 360 minus 286 is just going to be 74. So X is going to be 74 degrees right here. Great. So X equals 74, I guess. Okay, great. Now, something else to notice. Is 74 degrees, or is X, is that an inscribed angle? Well, it is, right? Well, it's not, maybe. Perhaps. It depends on how you look at it. But what you might really want to understand or look at is how it relates to the other angles. So you know this angle right here is a central angle, and it's going to relate to the outer arc right there. So is this going to do the same? Yes, it is. It's also a central angle, and that means this arc right here is going to be 74 degrees. Okay? So if this arc right here is 74 degrees, what is half of 74? That's just going to be 37. Go down here, 37. And that's going to be the correct answer. Okay. So for this problem, it's asking for E, F, and G. Okay. We'll skip this problem. It seems similar to the other ones. Okay. Same type of problem except with algebra. I'll do the algebra one. Right here. Okay. So it wants us to find the angle JIK. So we have JI then K. So it wants us to find what this angle equals. All right. Well, what do we know about our angle here and our central angle? Well, first, we know this is an inscribed angle because it's between two chords, right? This one is not between two chords. But we know this is going to equal our minor arc up here And so we know that this angle is going to be exactly half of our angle here. Okay, meaning that half of x plus 92, so x plus 92 over 2, so half of that is going to be equal to our inscribed angle, which is just 3x minus 19. Okay? Now we get the x's by itself. So first we have to get rid of the 2 in the denominator over on the left side. So to do that, we'll multiply both sides by 2. Okay. These cancel out. We're left with x plus 92 equals 2 times 3x is 6x. And then minus 19 times 2 is minus 38. Okay. And then I'm going to subtract the x from both sides. So we're left with 92 equals 5x minus 38. And then to get the x by itself, we'll add 38 to both sides. So, which is going to equal 130 equals 5x. Now to get x by itself, we divide both sides by 5. That x equals, what is 130 divided by 5? That is going to equal 26. Okay, is that our answer though? It is not, because remember, we're asking for angle JIK, so this angle right here. We want to know what this angle is. So we know it's 3x minus 19, but now we know what the x is, so we're just going to plug it right in. So it's going to be 3 times 26 minus 19, and that is going to be our answer. So 26 times 3 is going to be 78, and minus 19, which is a grand total of 59. So I is going to be 59 degrees. And there we go. Okay. Now let me do this problem. It's a little different from the last few we've seen here. Okay. So what is the value of x? Again, it gives us different angles, and but instead of giving us just straight angles, it gives us variables as well that we have to go through. Okay, well, what we see here is both 4x and x plus 27 are inscribed angles, right? And not only are they both inscribed angles, the arc that makes up their with their inscribed angle is going to be the same. So if we look here, JK, so JK and HJ are connected to this arc right here. And then we see HI and IK are also connected to the exact same arc, meaning that they're both going to be half of whatever this value is, meaning they're both going to be equal. Oh, that's great. That makes it a lot easier. So we'll just do 4x equals x plus 27. Okay, we subtract x from both sides. We're left with 3x equals 27. Divide 3 from both sides. We're left with x equals 9. Okay, what is the value of x? Same problem, just using some algebra. And same type of problem, just using some algebra. Something I want to note here is, and for this problem specifically, sometimes these IXL problems give you more information than you need. So for instance, it's asking you to find h, and you see h is an inscribed angle of this arc right here, right? So all we need to do is just half 82 which is 41.5. Okay, and that's going to be the value of h. Now it gives you like 136 up here, and you can figure out what the other two angles are there just by subtracting everything from 360 and dividing by 2. But is that information needed? It is not. Sometimes IXL, especially when it gets to the problems at the higher numbers, the higher smart scores, it's going to give you information you don't need just to keep you on your toes. So just kind of keep that in mind. Don't feel like you have to use everything. And there you go. Okay. And that's going to about do it. I think that's pretty much all the kinds of problems you'll see. Yep. This is just going to be half of this. Yeah. Okay. Well, that's where I'm going to end the video there. So study hard, stay safe, and talk to you later on the next video. Bye-bye.